Hi everyone. In the previous videos, means the comments related to the previous videos, many students were asked to give the difference between the primitive network and the partial network. So in this video, I'll just try to give the difference between the primitive network and the partial network in brief. So the meaning actually, first of all, let us understand what is meant by a primitive network. Okay, primitive network. Actually, the basic meaning of a primitive network is old. Primitive means old, or it is a basic network. To understand this, I'll just give a small example. Consider a circuit which contains various elements like consider this as a voltage source, this as a small resistor, and one more resistor here. Consider maybe an inductor or one more resistor like this. This is a circuit which contains various elements connected in this way. Now, so we can call this voltage source as one branch. This resistor, let us assume this resistor as R1 and this as R2 and this as R3, and assume this inductor as L1. Okay, so the voltage source can be considered as one branch, right? Consider this as B1. This is another branch which is B2. This is another branch which is B3, and this is the fourth branch which is B4, and this is the fifth branch B5. Okay, now each and every branch we can call it as a primitive network. Primitive network. The reason why we are calling each and every branch as a primitive network is without any single branch here we cannot form a complete circuit or a complete network, right? So here, for this example, each and every branch from B1 to B5 can be considered as individual primitive networks. Okay, this is one example from which you can understand the primitive network. Another example you can take from a power system scenario. So consider a three bus power system, for example. So here these are the three buses I am considering. Let us say this is bus 1, bus 2 and bus 3. These are the lines, transmission lines which are connected in between the various buses. Consider this as L12 and L13 and L23. These are the three lines between the three buses 1, 2 and 3. Okay, now we can consider, we can call each and every line as a single primitive network. Okay, so L12 as one primitive network, L13 as another primitive network, and L23 as another primitive network. Okay, so like that, the meaning of primitive network is nothing but a basic network, and these networks are needed in order to form a complete circuit or complete system. Okay, we cannot leave any one of this uh, element or one of the branch. We need to have all the branches or all the elements in order to form a complete network. Okay, so this is about the primitive network. Okay, and the other network which creates much confusion is partial network. Okay, we usually will just will have the confusion between the primitive network and partial network. Okay, so if you see the basic meaning of the words primitive and partial, maybe you will have less confusion, right? So now what is meant by a partial network? So partial network is one which is the, so here if you observe, the meaning of partial is nothing but an uncompleted network which is not completed. It may contain one element or it may contain 10 elements, but it should not contain all the elements. It is a uncompleted network. For example, for the same illustration or for the same example we considered in circuit theory, here I am considering the same example. You have a voltage source with three resistors R1, R2, R3 and an inductor L1 here. So we can call this network plus minus V, and this is R1 up to here. You can have a network here. This is not a complete network. Is it right or not? Maybe this network is a part of this entire network. As this is a part of this entire network, we can call this as a partial network. Okay, so it is a partial network of the given network. What is the given network? Given network contain the voltage sources R1, R2, R3 resistors as well as inductor L1. This is a complete network, but this is a uncompleted network, but it contains the elements which are in less number when compared to the elements in a complete network. We can also consider one more resistor here. So this is the one more resistor R2. Even you consider this network, this is also a partial network. Like this you can consider L1, and again it can be called as a partial network until and unless you consider all the elements including the voltage source. Now here, considering this example and the power system scenario, this partial network concept is basically used in building algorithm, uh, obtaining the Z bus matrix of a power system network using building algorithm, right? So there we have used the concept of partial network. Here if you observe, there are three lines in between the buses 1, 2 and 3. So here first will in obtaining bus impedance using building algorithm, what we will actually do is we'll add each and every element at a time until the complete network is obtained, until the complete power system network is obtained, right? So first of all, if I consider this network, this is a partial network. This is a complete network, but this is a partial network because it is an uncompleted network. Similarly, though you have considered the third bus and considering one more line L13, again this entire network is a partial network. Okay, then if you add the third element, now it becomes a complete network but not partial network. Okay, so in this way we can understand the meaning of partial network as well as the meaning of primitive network. If you know the basic meanings, what does it states, then there are less chances to have the confusion between these two networks. Okay, I hope you have understood this difference. Okay, we'll see in our next video. Thank you very much.